Students, this is an example of a compound gear train. This shaft, the motor is spinning, and notice the motor is going to spin this small gear that then attaches to the large gear on the next shaft. This is going to be spinning 7 times slower than this. But this large gear doesn't connect to the next shaft over. It's actually a small gear on the same shaft that connects over again to a large gear. So what we end up having here is each shaft in the line spins 7 times slower than the one before it. So we've got 7 times slower here times 1, 2, 3, 4. The gear ratio on this one is actually going to be 7 times 7 times 7 times 7, or 7 to the 4th power. What ends up happening then is this shaft has to spin around 2,401 times before this shaft spins around once. This is the type of gearing that you would see in a clock or in equipment that needs to have extreme speed or extreme torque. So if we were to actually switch the motor and put it instead on this one over on this one, we would be gearing for extreme speed. Unfortunately, I don't think this motor has nearly enough power to actually spin this gear, but if it could, then this thing would be flying around 2,401 times for every time this one spun around once, which is pretty cool.